Chapter 2.8, exercises 7 through 12, and this is section 2.8 in our book about solving inequalities, and polynomial inequalities specifically. Let's go ahead and look at, in exercise 7 through 12, complete the factoring if needed, and solve the polynomial inequalities, a sign chart, support graphically. And here we're given problem 7, quantity x plus 1 times quantity x minus 3 squared is greater than 0. Now basically, we have to look at our leading coefficient to figure out what's happening here. And you have x here in this quantity x plus 1 and x squared. So our leading term if we expanded this out, would be equal to x cubed. And x cubed is the basic x cubed parent function is like this, coming from low, odd, positive, going sideways right at the origin and going right back up. So that's what our basic parent function looks like. So our end behavior and behavior of this function is going to be similar to that as far as the end and the beginning. That really helps us to know about how many times it's touching the x-axis. Let's go ahead and solve for 0. In this inequality, if we set this, we're just going to go ahead and write this as a function. F of x equals quantity x plus 1 times quantity x minus 3 squared. And to find the zeros, we would set x plus 1 equals 0. So x would be equal to negative 1. And then we would set x minus 3 equals 0. So x equals 3. And this 0 of minus 1 is going to have a multiplicity of 1. And this one, since we have a double root, this factor x minus 3, this 0, 3, since we have squared to the second power, this root will have a multiplicity of 2. So that's going to really make a difference on what we're looking at. So the sign chart is really drawing the horizontal line and putting these critical numbers, these zeros, on here. And we have 1 at x equals negative 1. I'll put it below, put the negative 1 below. And at x equals 3. So that sign chart is going to help us solve this. And basically, with this function here on the left, we're going to look at this. We're coming down from below, and we have a multiplicity of 1, meaning at x equals 1, we're going to have a change. The function is going to cross the x-axis. And so coming down from below, we're going to have a negative sign. And then we're going to go up between 1 and 3. And so that's going to be above the x-axis. So we put a plus between 1 and 3. And then at 3, we have a multiplicity of 2, meaning that instead of going back with the even numbered multiplicity, we're going to bounce off the 0 at 3 and keep on going up. If we had an odd number multiplicity, like multiplicity of 1, 3, or 5, we would continue to go down, and we'd have a sign change. So at 3, we have no sign change. And so we're going to solve this inequality for greater than 0. So basically, what we're looking at is we have our solution set is, and we have greater than, so that's going to be parentheses, we have greater than 0 between x equals -1, greater than -1, all the way up to, but not including 3, because at 3, the thing is 0, union, and then we have this break at 3, so we resume at 3, and we go to less than infinity. And then lastly, we have, it says support graphically, so we go to our graphing calculator, and I'm going to go to where I entered this function previously. You have here quantity x plus 1 times quantity x minus 3 squared. Press enter. I'm going to get a slightly different, I want to get a different window here to see that maximum. Menu 4, window setting. I'm going to come down here to -10, and 20, and here, press enter. So we see this, we see that the function value is going to be greater than 0 between -1 and 3, and again from 3 to less than infinity. So our sign chart has not led us astray, and we are confident of our answer, supported graphically. Okay, next, odd number problem 9. We have quantity x plus 1 times quantity x squared minus 3x plus 2. And the thing says complete the factoring if needed. Well, let's go ahead and do that, because I don't think we have completed factoring here, do we? If we have this as a function, enter this as a function, we're going to have quantity x plus 1 times, and I want to go ahead and factor out this quadratic trinomial. So for that, we have x squared minus 3x plus 2, so I'm going to put x squared in the upper left, plus 2 in the lower right, and the factors of x squared are x and x, that's easy. And our factors of 2, well, we're going to have either 2 times 1 or -2 times -1. And here our middle term is negative, so we should have -2 times -1. We'll just see if this works out. -2x goes in the upper right, and -1x or -x in the lower left, and combined, -x plus -2x, that's going to be -3x. So that's going to work out. So our factors, our other factors, are going to be quantity x minus 2 times quantity x minus 1. And now to find our zeros, we set x plus 1 equal to 0. Our second factor, x minus 2, is equal to 0. And our third factor, x minus 1, is equal to 0. So our zeros are, solving for this equation on the left, x equals -1, then x equals 2, then x equals 1. So those are the zeros we have, and we're going to have x times x times x, so we're talking about, again, a cubic type relation, and each one with multiplicity of 1. By the way, let's put multiplicity of 1. Multiplicity equals 1. Multiplicity equals 1. So we're going to look, it's going to look something like this. Let's see, I think it's going to go something like this. So let's get out our sign chart. Create that using our horizontal line. And we mark our zeros. From the left, we have -1. We have x equals 1. And we have x equals 2. And from the left, Again, this general shape, we know to the left of 1, we're going to be below the x-axis, so that's going to be negative. Between -1 and +1, we're above the x-axis, that'll be positive. Between 1 and 2, we're going to be below the x-axis or negative, and greater than 2, we're going to have positive. And so that's going to make our solution set, we're going to be less than solution set. We're looking for less than 0, so where we have the negative sign, we're looking at greater than negative infinity, comma, -1. And then from -1 on, we're positive till 1, so union. And we're less than 0 again at starting with greater than 1 to less than 2. So really that should be our answer. Let's go confirm graphically. Let's see, graph, go here. Okay, this is our equation entered, unfactored, but we just press enter, and we see a 0 at for negative from negative infinity, it's -1, and then between 1 and 2. So we have graphical confirmation. So this would be our correct answer right here. Okay, next odd number problem, which is 11. In this case, we have a cubic polynomial with 4 terms. It is completely unfactored. I'm just going to start by rewriting this as a polynomial function. I'll put f of x equals 2x cubed minus 3x squared minus 11x plus 6. And as far as factoring this, because we don't have this factored at all, we have to figure out what the zeros are or what the factors are. And to do that, we can use the rational zeros theorem. Or let's do this. I want to use instead the remainder theorem. The remainder theorem, I think we worked on that back in section 2.4. But let's figure out the rational roots first. We're going to have 6 factored, or plus or minus the factors of 6, which is the last term, over the factors of 2. So that's going to be plus or minus. Our factors are going to be 1 times 2 times 3. So it actually could be 6, or it could be 6, and then we have 2 and 1. So we have a potential list of factors that's pretty large. So we can have plus or minus 1 over 2 plus or minus 1 over 1, and then using the 2, that's 2 over 2, and then 2 over 1. It's 2 over 2, we already had that. So we can have plus or minus 2. That's a possible, those are possible zeros. And we can have 3 over 2, which is going to be plus or minus 3 over 2. We can have plus or minus 3 over 1. And then we can have 6 over 2, that's going to be 3. Or we can have 6 over 1, which is going to be plus or minus 6. So that's kind of a long list of possible zeros. And I like to use the whole number ones first, like the 1 and 2, to make the arithmetic easier. So if we plug in a 0, we can try 1. And if we plug in 1, f of 1, we get 2 times 1 cubed minus 3 times 1 squared minus 11 times 1 plus 6. If all this simplifies to 0, well then we've found a 0. Well, so we have 2 minus 3 minus 11 plus 6. That's going to be 2 minus 3, that's negative 1, minus 11, that's negative 12, it's going to be negative 6. So 1 is not a 0. We can try f of negative 1, and same type of process here. We're going to have 2 times negative 1 cubed minus 3 times negative 1 squared minus 11 times negative 1 plus 6. And for that, let's see, we're going to have negative 1 cubed, it's going to be negative 2. We'll have negative 3 minus 3 minus minus, that's going to be plus 11 and plus 6. Negative 2 minus 3, that's going to be negative 5, plus 11 is 6, plus 6 is 12. So we know that 1 and negative 1 are not zeros. We'll try now 2. F of 2, we have 2 times 2 cubed. And then we have minus 3 times 2 squared minus 11 times 2 minus, or is it plus 6? Plus 6. So here we have 2 cubed, which is going to be 8. 2 times 8, 16. Minus 3 times 2 squared, that's going to be minus 12. Minus 24, right? No, yeah, 22. It's 22 plus 6. That's going to be negative 4. Minus 22 is negative 18. Plus 6 is negative 12. So negative 2 is not, so 2 is not a 0 either. Okay, we're just going down a list here. Once we have 1, we're going to be in good shape. Okay, we have 2 times negative 2 cubed minus 3 times negative 2 squared minus 11 times negative 2 plus 6. And that's 2 plus 6. So for this, we're going to have this negative 2 cubed is going to be negative 8, so we're going to have negative 16. And then we're going to have minus, let's see, that's going to be negative 2 squared is 4, so we have minus 12. And plus negative 11 times negative 2, 22, plus 6. I think we're going to be looking pretty good here. Okay, negative 16 minus 12 is negative 28, and 22 plus 6 is 28, so we're going to be 0. So finally, one of our zeros is going to be, when we factor this equation up here, let's see, this function. I'm going to rewrite the function here. F of x equals 2x cubed minus 3x squared minus 11x 11x plus 6. And then f of x in factored form, if our 0 is negative 2, one of our factors is going to be x plus 2. And then we're going to get our other factors here. So that's going to be x plus 2 equals 0, and x equals negative 2 in multiplicity of 1. Okay, next, we're going to need to find the remaining factors of this thing, and to do that, I'm going to come down and do a division, a synthetic division, and our 0 is negative 2, and we put our terms here, 2, negative 3, negative 11, 6. So we have 2, which is going to be the x squared's place. We get 2x squared, negative 2 times 2 equals negative 4. Negative 3 plus negative 4 is negative 7. Negative 2 times negative 7 is 14. Negative 11 plus 14 is 3. Negative 2 times 3 is negative 6. So we have 0. So our other factor, we have 2x squared minus 7x plus 3. And we need to factor this guy here, and to do that, we're going to have 2x, x, and we're going to be minus 7x, so we're going to have minus 3, let me see, 3, get negative 7x, I think it's going to be 2x, right? Yeah. So 3, we're going to have minus 3 here, and minus 1 here. So we're going to have negative 3 times 2x, that's going to check. So our remaining factors up here are going to be 2x minus 1 times quantity x minus 3. And so we have 2x minus 1 is equal to 0, meaning if we solve this equation by adding 1 dividing by 2, we'll have x equals 1/2, and that's a multiplicity of 1. And this last one, we have x minus 3 is equal to 0, so x equals 3 is our remaining 0, and that's also a multiplicity equal to 1. And now we go ahead and make our little chart. And again, we have a cubic function and positive cubic function. So we start from the left. We go our 0 at negative 2, our 0 at 1/2, and our 0 at 3. And so for our sign chart, to the left of negative 2, we're going to be negative. We cross the x-axis at x equals negative 2 with a multiplicity of 1. So between negative 2 and 1/2, we have positive. And we're up above, and we come down below at x equals 1/2 to go below the x-axis. And then we exit above the x-axis at x equals 3. So that is our sign chart. Now what are we looking for? Looking for greater than or equal to 0. So our solution set is going to be greater than or equal to negative 2. Now in this case, we have greater than or equal to, and between negative 2 and 1/2. Again, greater than or equal to union, and we're going to have greater than or equal to 3, comma, less than infinity, and we got to close off that infinity with a parentheses. So everything looks good here. Let's go one more step and graph this thing. Control I, graph. We go to the last function entered, and this is in unfactored form, just typed in from originally. There it is. I'm going to go make a little better sketch to get better aspect ratio. Zoom 4, window settings, come down here to negative 25 for our y min, positive 25 for our y max. Press enter. And we see we have greater than or equal to from x equals negative 3 all the way to 1/2, and from 3 to less than infinity. So that confirms our answers. So to me, the hardest part of this was factoring out that cubic polynomial, but with the remainder theorem, we were able to do that. You can see, while tedious, the arithmetic shouldn't be that hard. So good luck on your even number problems, and thank you for viewing.